Hello, good afternoon guys. Welcome to Physics Laboratory online class. So right now I will be doing experiment number 7, which is the speed of mechanical waves. We have 3 objectives for this experiment. Number 1 is to examine how the tension is required to produce a standing wave in vibrating stream of fixed length and mass density as affected by the wavelength and frequency of the wave. The second is to determine the speed and wavelength of the wave. And last is to verify the relationship among the wave speed, wavelength, and period of oscillation or vibration. We can define wave as the disturbance of in a meter. Okay, and then waves can be classified as mechanical waves and electromagnetic waves. For us to classify a wave as mechanical waves, there should be a medium. Okay, and then the missing medium can be a gas, solid, or liquid. And mechanical waves can be classified as transverse wave and longitudinal wave. Okay, the first part of our experiment is about transverse wave, in which we're going to have the vibrating streams, and then the second part is longitudinal wave, in which we're going to study the speed on wavelength of some wave. Okay, for this part, okay, so we will be discussing about the transverse wave, but before that, so what is the difference between transverse wave and the longitudinal wave? Transverse wave is a wave in which the direction of vibration is perpendicular to the direction of the motion of the wave. So the direction of vibration is this one, up and down. So the direction of motion of the wave is perpendicular, so that's going there. Okay, so the vibration is up and down, in which that is perpendicular to the direction of the motion of the wave. For the longitudinal wave, the direction of motion of the wave and the vibration is parallel to each other. Example of that is sound wave. Okay, so to start with the part 1, okay, so that's about vibrating stream. Okay, we will be needing all this equipment. Okay, so this one is called the sine wave generator. Okay, so this can be used this way. Okay, so this one is we can turn on or off on this part. Okay, so this one is set to 100. Okay, so meaning the frequency here is 100 hertz or 100 vibration per second or 100 per second. Okay, attached to this one is called the string vibrator. Okay, kung mapasin nyo, if I'm going to change the frequency, there's also changes in the vibration. Okay, so the vibration is caused by the vibrating or the string vibrator. Okay, and of course we have the string, and then the string is attached to the force sensor. We attach the force sensor here for us to measure the tension or the force in the string. Okay, and then of course we have the force sensor, and the force sensor is attached to the GLX. And we all know that the GLX is used to measure and also store the data measured by the force sensor. Okay, again, the force sensor is used to measure the force and tension in Newton. Okay, in our table, in the experiment, okay, so we need to identify the experimental and theoretical value of the wave velocity. So for us to compute for the experimental value of the wave velocity, in which the formula is this one. So this is the formula to get the experimental value. So we have wavelength multiplied by frequency, and then for the theoretical value, this one, theoretical value, we're going to use this formula. So this is equal to the square root of FL divided by M, in which the F here is the tension in the string or the force, L is the length of the string, and M is the mass of the string. So meaning, we need to measure the length of the string, and also we need to measure the mass of the string. Okay? So we have here the string. So what we did a while ago is, we already measured this one using the loading balance. So based on the measurement kanina, so the mass of this string is 2.11 times 10 to the negative 3 kilograms. Okay, so that is the mass of the string. And then for the length of the string, of course, we need to use this steel tape. Okay, so based on my measurement, so this is 132 centimeters. So 132 centimeters, so we need to convert that to meter. So that is to be divided by 100, so that's 1.32 meter. Okay, so that's the length of the string or the L in the equation. Okay, and also, but before that, I will be writing here the data. Okay, again, so the mass of the string so based on the top loading, that is equal to 2.11 grams or 2.11 times 10 to the negative 3 kilogram. And then the length of the string is 1.32 meter. Okay, so the length of the string will be constant, okay, for 2 segments and 3 segments. That is also 1.32 meters. Okay, then the target now is to create different number of segments by adjusting the frequency in the sine wave generator. Okay, so the target is to create one loop or one segment, 2 segments, and 3 segments. Ano ba yung 1 segment, 2 segments, 3 segments? Okay, that is also illustrated here. So this is the 1 segment or 1 loop in which the number of node here is 1 or the number of segment here is 1. This 2 is the second row, which is n equal to 2 or the number of segments is 2. And then we have here the number of segment here is 3. Okay, ito yung target natin gawin. Okay, so I will start with the creation of the loop, which is 1. Okay, what I will do is I will adjust the sine wave generator. Ang gagawin ko, I will be setting the amplitude at this part lang, hindi ko siya babaguhin. Okay, so that's 6 Hertz, 7, 8, 9, 10, 11, 13, 14, 15, 16. Actually, nagkakaroon na siya ng 1 segment. Pero, hanapin ko yung pinakamagandang 1 segment. So, this is 18 Hertz. Okay, so nawala na siya. So, 19 Hertz na to, then nawala yung ating wave. So, babalik ako sa 1, then ulitin ko hanggang makaproduce ako. So, nawala siya sa 19, siguro nasa 18 lang siya. Okay, so this is 15, 16, 17, 18. Kanina nang ginawa kong 19, nasira na yung wave. Okay, so here the frequency is 18. So I'll be putting the 18 Hertz here. So this is 1 segment, frequency is 18 Hertz. And then I need to compute for the wavelength. But before that, tingnan ko muna yung tension. Okay, yung tension can be read in the GLX force sensor. Okay, so ang ginawa ko kanina is sinet ko yung GLX Explorer sa average. Okay, based on the reading. Okay, so medyo nabago ulit. So balik ako dito sa sine wave generator kasi nawala yung wave. Ulitin ko siya. Kasi dapat hindi mawawala yung 1 segment or yung wave. Okay, this is 14, 15, this is 16 Hertz. Kanina nasa 18 Hertz, pero nawala naman siya. 17, 17, 18, 18 nawawala. So, balik ako sa 6, 7, 8, so this is 14, 15, 16, 17, okay, so this is 17 Hertz. Baguhin ko yung data ko. Kanina 18 siya, pero nawala naman. So, 17 Hertz siya. The same length, 1.32 pa rin siya. And then, yung force dito is the average. So, average is 3.02 Newton. So, force is 3.02 Newton. Okay, and then Wavelength, we have the formula for wavelength. Okay, para ma-compute yung wavelength, we're going to use this formula. Okay, this one is the formula for wavelength. Okay, so the formula is wavelength, okay, or lambda is equal to 2L divided by N. Okay, the L here is the length of the string, N is the number of segments. Okay, so in this case, N is equal to 1 kasi one segment lang naman siya or one loop. So we have the measured value of L, which is 1.32 meters. So what we need to do is just substitute the value 1.32 meter over number of segments na 1. Okay, so this is 2.64 meter. So that's the wavelength for segment number 1. So I'll be putting here the 2.64 meter. So we need to compute for the experimental value and theoretical value. Okay, again, experimental value is equal to this formula. So that is simply wave velocity is equal to the wavelength multiplied by frequency. Again, yung wavelength, ito yung kinompute natin using the formula 2L over N. And then yung frequency, ito yung sinet natin sa sine wave generator. Okay, we just need to multiply the two for us to get the experimental value. So experimental value is equal to, again, the formula is wavelength multiplied by frequency. So wavelength is 2.64 meter multiplied by frequency na 17 Hertz. So 2.64 multiplied by 17, so the answer is 44.88. So this is 44.88 meter per second. So the experimental value is 44.88 meter per second. Now, we need to compare that to the theoretical value. Yung formula natin yung theoretical value is FL divided by M. So theoretical value is the force read on the GLX multiplied by the length of the string divided by the mass of the string. Okay, yung reading natin kanina is 3.02. So the tension in the string is 3.02. So that will be 3.02 newtons multiplied by 1.32 meter at yung length ng string over 2.11 times 10 to the negative 3 kilograms, which is the mass of the string. Okay, so this one is equal to 3.02 times 1.32 divide by 2.11 raised to negative 3. So the answer is 1,889 square root of that answer. So this is 43.47 meter per second. So the theoretical value is 43.47 meter per second. So close na yung value so for sure in percent error natin maliit lang. Again, the formula for percent error is experimental minus theoretical divided by theoretical multiplied by 100. So that will be 44.88 minus 43.47 divided by the theoretical value, which is 43.47, okay, multiplied by 100. So the percent error is 3.24. Mababa lang siya kasi yung target natin is less than 10. Okay, so that's for one segment. Now I will be creating the two segments. Okay, paano gagawin? Adjust ko lang ulit itong sine wave generator. And then kailangan makapag-produce ako ng dalawang segments or dalawang loops. Eto, dalawang loops na yan. Pero hindi pa siya stable. Sisira na siya. So balik ako sa 35. I think hindi ito yung pinaka-stable. Yeah, so I set ko siya sa 34. Okay, so we have two segments here. Frequency is 34. So for number 2 segments, this is 34 Hertz. Okay, and then yung force dito is Force is 3.11. So force is 3.11. Okay, compute ko lang yung wavelength. Now, this time, we have two segments. So kanina, n is equal to 1. Ngayon, for two segments, n is equal to 2 na. Okay, so wavelength is 2L over n ulit. So that's 1.32 meter over 2. So this is 1.32 meter. So wavelength here is 1.32 meter. Okay, I'll be computing for the experimental value. So experimental value is simply the product of frequency and wavelength. So that's 34 multiplied by 1.32. So the answer is 44.88. The same lang dapat siya. Okay, so 44.88, then I'll be comparing that with the theoretical value. Again, the formula is this one. Theoretical value is, paltan lang natin to, kanina 3.02 sa one segment. Okay, so two segments, ano na siya, 3.11. So 3.11 newtons, 1.32 meter, constant naman yung mass. Okay, so speed of the wave is 3.11 times 1.32 divided by 2.11 square root. Okay, this one is 44.11. So this is 44.11. Okay, then the same process, you compute 40% error. Now I will be changing the number of segments into 3. Okay, I just go dito. The target ko is 3 segments. Okay, actually 3 segments na siya. This is 1, 2, 3. Hanapin lang natin yung pinaka-stable. This is 47, 48, 49, 50, 51, 52. Nawala na siya. So balik ako sa 39 muna. Hanapin ko lang yung 3 segments. 48, 49, 50, 51. I think yung 51, ito yung pinaka-stable. So, frequency is 51 Hz. Okay, and then n is equal to 3. So, wavelength is 2 times 1.32 meter. So, this is 2L. Okay, over 3. So, this is 2 times 1.32 divided by 3. So, the answer is 0.88 meter. So this one is 0.88 meter. Okay, multiply the two to get the experimental value. Okay, so that's 0.88 multiplied by 51. So this is equal to 44.88 pa rin. Okay, yung value ng velocity should be the same kasi ang ginagawa lang naman natin is binabago natin yung frequency and then of course nagbabago yung wavelength niya. Okay, so the velocity will be the same. Okay, now let's check at the tension or the force. The force here is, the average is 2.91. So the tension is 2.91. So let's compute for the theoretical value. So that is equal to 2.91 multiplied by the length of the string divided by mass of the string. Okay, speed of wave is equal to 2.91 times 1.32 divided by 2.11 negative 3 square root. Okay, so the answer is 42.67. So this is 42.67. 42.67. So medyo malaki lang yung error. Okay, so ipakita ko lang. Okay, so again, the target is 10% below yung error. So 44.88 minus 44.11. Ito obviously maliit lang yung error dyan. Okay, divide by 44.11. Okay, so this is equal to 1.75. Eto, medyo malaki itong sa 3 loops. 44.88 minus 42.67 divided by 42.67. Okay, times 100. So, this is 5.18. 5.18 pero below 10% pa rin siya. Okay? Eto pala. So, the mass of the string, dito ko lang ilipat. So, this is 2.11 times 10 to the negative 3 kilogram. Okay, so this is how to do the part 1 of experiment number 7, which is explain mechanical things. Okay? So, isa lang namin yung para sa part 2 and then hindi ko ulit. Thank you.